Welcome back to our channel Easy Peasy Robotics. We discuss the robotic concepts to help the community to build better systems. And today we will discuss how to create a workspace, packages, publisher and subscriber, and how to have a communication between them. And let's proceed without wasting any time. Let's proceed with the video. So the first thing you have to do is go to your home directory and then search for, press Ctrl and H, and then go into this .rc file. So now I assume that you have already ROS2 installed in your system. The thing you have to do is copy paste this line over here in your .rc file. So this will source the ROS Humble into your current terminal, so that you don't have to run source your ROS2 again and again. So just keep this in your .rc file. So once you're done, Ctrl C, Ctrl S for save, and then close this. So let's begin further. And then in order to install, go to your Chrome and type ROS Humble documentation. So here you will have all the documentation of the ROS, but we will proceed further with the tutorials in these client libraries. Go to using Colcon. Yeah, now open your terminal, right click always on top so that it stays on top. Now you can see, to build the packages and all, we need the Colcon. So in order to install Colcon, you copy paste this so that you will have first the Colcon, that is you enter the password which is required to build the packages. So I have already this Colcon, so it hasn't installed anything over here. So once we are done with this, let's create a workspace. So this command, just scroll down and select for Linux if you are working on Linux, and this command will create a ROS2 Workspace, which is just a folder, and in which you will have an SRC folder in it. And then CD refers to the change directory, and then we will enter the ROS2 Workspace over here. So this is just for now creating the folders. So copy and paste. So for now you can see I don't have any ROS2 Workspace over here. So when I enter this, we can see that we have the ROS2 Workspace. For better visualization, let me open this with the Visual Studio Code, so that we know exactly what is happening over here. So let me create this over here and this will over here. So now we can understand what's going on. So let's see now, in the ROS2 Workspace, I only have a SRC folder, and in it I don't have anything. So what was all these things for now? Let's do this thing. So whenever you are in your ROS2 Workspace, then only you will do the Colcon build. So this will build your workspace. So what it exactly do is it will make the build, install, and the log folders in it. So the build will have the intermediate files of the system, and install will install all the packages into this folder. But for now we don't have any package, so it will not install anything. And the intermediate, the log, will have the various log information of the package. And with this extension, you don't have to change your Python files again and again. Once you made, you don't have to build it. So that's why this will make your life way more easier. So what we do, we copy this, make sure that you are in the ROS2 Workspace. If not, then use CD and then use this command to go into the workspace, and now copy paste. Now look at these files. I only have SRC. So when I do this, you can see I have build, install, and log. So these are the files which are built by the system, so you don't have to worry about those for now. And then, so whenever you have this, when you have the packages you have installed, to update this environment in the terminal, you have to source this setup.bash file, which is in this install. Here we can see this is setup.bash. So you have to source that to have the updated in your terminal. Now let's clear this. So now we have this. So we have the workspace. So with this we have created the workspace, and for understanding of what is a workspace and what are the packages and how we can organize them, let's move towards the theoretical understanding of that, and then we will implement our own. Now this is the workspace that we have already created, and which already now, and we have created the SRC file, and these are the files which were already built using Colcon, which will have build, install, and log. So in SRC file, we will create all of our packages, and in SRC you can have multiple packages. We can see package 1, 2, and 3, and you can have many more over here. And that's how you put all of your packages. So once you build Colcon build, it will install all of these packages into this install folder, and which you have to source to have the updated version of the packages which you have built already. So that's how you can have all the packages. And let's see the structure of the package and what it looks like. So here we can see this is a package name, my Python package, and the files which are in this blue section will be already created by the package when you create a package. So it will consider the package XML file which contains the metadata of the package and the details of the maintainer, that is you, and setup.file which will have all the install dependencies as well as the entry point to your nodes, so which will make the nodes executable. And setup.config will tell the system where to install, what to install, and to link the dependencies, and it will have resources which you don't have to worry for now. And then you will have a folder name which will be same as of your package name, and this will have init.py already. And then in this folder, which is the same as of this your package name, then you will create the number of nodes, that is publisher, subscriber, and so on. And then you will put all of your nodes over here, and then you manage them like this. And now, so once we have this, if you have created your own messages, then you create one message directory, that is a folder in your package, and then you put all of your messages over here. And if you have services, you create a service folder, you put all of your services, similarly launch files and the config files. So that's how you organize the whole package. So once you do the call on build, it will build all of this, and so that all the executables will be known to the system, and how the dependencies required and everything. So that's how it will make the package. So when you have multiple packages, still you can organize them using the call on build. It will build the packages and it will have the executables. Let us create a package now. So in this, go to write a publisher and subscriber in Python, and in that scroll down, and to create a package you have to copy this command over here. So ROS2 package create, this will create the package. So here it is showing the build is mn.py and the license, and you go to make sure that you are in src. Over here you can see in the terminal in the workspace in the src, and then you copy paste this command. And in this, let's change the name of the package. So this considers the package name. So now we will type learning package. We are creating our own custom package. So learning package. Now when you enter, you can see over here in src, in the src I don't have anything. So when I do this, it will create all the packages. It will create the learning package. Learning package has resources, test file as well, but we are not interested. So the package.xml file and setup.py file, these are the two most important for us now. And in this learning package, we have another folder, that is learning package. If you see, it has init. So here we will create our nodes, the publisher and subscriber for now. And now let us create a Python file over here. In this, right click and new file. We will create publisher.py. Okay, so this is the file we have. And one more thing you have to do is go to your home directory in this ROS2 Workspace, src, learning package, which has a learning package. Here is a node. So you have to right click, properties, go to permissions, allow executing this file. So this will make the file executable. So this you have to do it whenever you create a file over here. So now you have this package, copy paste this whole thing for the publisher. I will explain this command, what exactly over here this is doing. But before that, since we are using RCLP and standard messages over here, we have to open this package.xml. We have to add that the dependencies for that. And here you can see this, copy paste this, and you have to paste over here. So this will say to the package that we are using RCLP and standard messages, and these are the dependencies that we have. So let us understand what exactly happening in this publisher. So we import this ROS CLP. RCLP refers to the ROS client library for Python. So for creating the nodes, here we are importing the node. Yeah, it will be better over here. So we have from RCLP, we have this node, and so this node will be used to create our initialize the node and to spin the node and so on and so forth. And this is the message type we are using. So with this publisher, we are publishing a message which is a string. That is over here it is hello world. So this is the string that we want to publish. So that's why we have to use a message type, which is this. How do you know that we will use this message? Go to a new terminal and type ROS message for string value. If you have to send a string value, here you can see standard messages. So what it is doing is from standard messages, it is taking string.message And if you want to see this, open a terminal, open a new window. Please go to ROS2 interfaces. Interfaces here refers to message, and then you can go for the standard messages. Okay, show and tab, it will complete it, and then you have to type std standard messages message, and you have to see, if you double tap, then it will show you all the things you have. So here we have standard messages string. So here you can see all the message types that we have in this standard messages. And over here, if you see, then how we are importing this is from standard messages dot message, we are importing the string. That's what we're doing over here. So that's how you can use the different message type. If you are doing int, then you can use standard messages dot message, import int. So that's how you can publish the int value and so on. And you can have many different, you can explore all the options that we have over here for the messages now. And so once we have import all of this, and we have to add this in the package.xml, which we have already done. And next, so from here, the setup, you have to, so this function we'll call this main function. So the main function will take the argument as a node, which is from this rclp.node, and this will initialize this node. It will say to that this Python script is a node, and then we will have the instance of this class, which will taking the node, which is inheriting the node class, and with this you can create your own publisher and so on. So, and this rclp.spin will spin this node continuously, so that it will be continuously publishing the data. And once you type Ctrl+C, this will shut down the node, that it will destroy the node. And when we create this, it will call the init function, as you know, in Python. So with this node, now self.publisher will be create publisher. Here we are creating a publisher to send the message, and this is the message type. We are sending a string, which is over here, the same. And then this is a topic name. So this topic name, you will decide what it will be. And this is the queue size, that is how often you have to send. So this is timer, that is 10 messages per second. It will send 10 messages per second. Here is a timer, is also provided, create timer. So how often we should call this function, which publishes the message. So we are calling it like 0.5 seconds, each 0.5 seconds. It will call this function, that is timer callback, which is over here. So this will call the timer callback every 0.5 seconds. So in this, what we are doing, so this is the main function, that is preparing message and sending the message. Over here, message type is the string, which is from here we have imported, and in this message we are encoding the data that we have. So message.data, how do you know that message dot, here we have to write data. If you go to this message type, here you can see standard message string dot message, and then a string which has a variable that is data. So data encodes the string value. So if you see message is equal to string, and message.data will contain the string. Over here, this is hello world, and this is the count we have for 1, 2, 3, 4. And once we have this data, the message, then we have to use this publisher, which we have created over here, the publisher, and then we will publish this message. And this is just for having the output, and this will increase the count. So like this. So whenever we run this code, it will go to this main function. From here, it will go to this instance and init, and it will create a publisher, and it will at 0.5 second it will call this timer function. Timer function will have this message, and it will take this message and it will publish it on this topic. This is the topic name. So this is the publisher part, and this is what it does. And we have added the dependencies now. Now we have to go for look for the subscriber. This is a subscriber node we have. And now in order to make a new file and then make it executable, the best practice is to copy and paste, and then rename this file. We can rename this file from here. You go to rename, and then you make it sub.py, which is subscribe. So this is the publisher which will publish the data, and this is the subscriber that will subscribe to this message over here. And now we copy paste this data into the subscriber. The subscriber, we select, remove this, and then add this data. So what actually happening in the subscriber is, this also follows the same. It has to have the same string. It has to take the node, and again we will call the main function. Over here it will call the subscriber, and it will continuously spin it so that it should be continuously listening over the topics. And once you type Ctrl+C, it will stop this node. Okay, so once we go over here in the init, we are creating a subscriber using the sub.create subscription. Okay, and the topic name has to be same as of the publisher. The topic name has to be same in order to listen to that message, and then it will call this. So whenever it receives a message on this topic, it will call this function, and this is the queue size again. And therefore, so whenever it calls this function, we will go over here, the listen callback, and we will take this message from the publisher that we have on this topic. So when we have this message, we are over here just printing the message, that is message.data. So whatever the string that we are publishing from the publisher node, so this node will subscribe to it, and it will show whatever that it is listening. So over here what you can do is you can take this message and you can manipulate it. If you have an integer over here, then you can add the integer to make it +2 something, and you can do the further processing of the data as you please. So this is how we have created the publisher. And now one more thing we have to do over here is go to your setup.py file over here, and you need to have these entry points over here. So this will tell the package that these are the files that the system knows, so that the system knows what exactly happening. So over here, if we say, we will change this to publisher, and this has to be the package name. In our case it is learning package. In the learning package we have, this is the file name, that is pub.py. So we have the pub, and in that it will call the main function. So that the whole thing over here refers to the pub. So now whenever you are running the code, you can just use pub, and it will execute the main, it will call the main function of the pub file of the learning package. Similarly, you do it for the subscribe. Let's do it for that. So this is for the subscriber learning package, and this is subscriber.py. So now we are done with everything. Now we have to build the workspace, and then we have to source it. Those are the two things that we have to do. So open your terminal over here, and then if you click the upper arrow, then it will show you the history of commands that you have. So colcon build, always make sure that you are cd change directory ... will take you to the previous directory, that is in the ROS workspace. Then only you do the cloning, the building. So colcon build, and this will build the package. It is just giving a warning that this is deprecated, but you don't have to worry about that now. So once you have this package, to have the updated version of it, you have to source it. Source install setup bash, and if you press tab, it will autocomplete some of the details, and then you do this. So we are done. Now in order to run the nodes, we have to type ROS2 run. This is the command which is used to run the codes, and then package name, that is a learning package. If you press tab, if you just write LE and then press tab, it will complete, since it taken as a package now. And then we have pub p and tab, so it will auto-complete. So when you do this, we can see it is publishing hello world. So this is a string message that we are publishing over here. And now for the subscriber, again source, we have to go back, and then you do source install setup.bash. So once you have this, again to load the another ROS2 run learning package subscribe. So you see, I heard hello velocity. So what is happening over here is, this is the publisher which is publishing this message hello world 60 62. This is the count we have, and then this is the subscriber that is listening to that message. So here we can see it is listening to this message over here. So that's how we are having the communication between these two nodes. Similarly, you can transfer a huge amount of data from one node to another node, and then you can do the further processing. That's how you build the robotic systems. So with this video, we have completed how to create your workspace, publisher, subscriber, how to create the packages, and so on. And in the next video, we will see the other details that are required to build the packages. And with this, if you are watching this playlist from the beginning, so from this we can do a lot of things in robotics, and we will discuss the ROS and gazebo in the next video, which will give you more details on it, and with which you can at least build the smaller projects in robotics. Thank you for watching, and we will see in the next video. See you. Bye bye.